student. So in this video we are dealing with the intersection of lines, and then we shall see the intersection between lines and curves. So what is here, what is there to remember? If two lines are intersecting, if I call this one L1 and I call this one L2, the point where these two lines intersect, the two lines are equal. Where they are intersecting, they are equal. Meaning, if they say that find the coordinates of the point where the following pair of lines intersect, this line and this line, I can simply solve the two simultaneously, as simple as that, because here they are equal. Or else I can express each in terms of y, and equate the two values of y, because at the point of intersection the two lines are equal. So I can say that either my first working, I solve simultaneously, so that I have x plus 2y is equal to 2, and then 3x minus 2y is equal to 14. I can do elimination by simply adding the two. When I add the two here, I get my 4x will equal to 16. Divide through by 4, divide by 4, by 4 once, by 4 once, here 4. My x is equal to a 4, such that I go in n either 1 or 2, and then I substitute in the value of x. So if I choose the first one, so I have 4 plus 2y is equal to 2, such that I can take it the other side. My 2y is equal to 2 minus 4. My 2y is equal to negative 2. I divide here by 2, divide here by 2. My y is equal to negative 1. But they've not asked me for the values of x and y. They have asked me for the coordinates of the point of intersection. So therefore, the coordinate of the point of intersection is x is 4, y is negative 1. But I have said that this is the point of intersection. You can interpret it as a phenomenon in such a form that at the point of intersection the two lines are simply equal. Meaning I could come where I have here x plus 2y is equal to 2, and then the other line is 3x minus 2y is equal to 14. So I could make y the subject, that I have my y will equal to 1 minus a half x, 1 minus a half x, because the x crosses the equal signs. Then if I take here, I can have my negative 2y is equal to 14 minus 3x divided by negative 2. My y will equal to negative 7 plus a 3 out of 2x. So what I simply do, I equate the two values of y rather, because at the point of intersection the two lines are equal. So I have equating the y values. So equating the y values, because they are simply values of y, they must be equal. So I have 1 minus a half x will equal to negative 7 plus a 3 out of 2x. I bring the 7 this side, such that I take the half the other side, so that I have here a 2x that is equal to a 1 plus 7, which is an 8, such that divided through by 2x will equal to 4. And then when you substitute in, you get your y as equal to negative 1, such that the coordinate becomes 4, negative 1. So you choose any of the simplest methods for you. In the next example, let's do the intersection of a line and a curve. Okay, so on our intersection between a line and a curve, what do we need to know on the intersection between the line and a curve? So maybe solution, but before we go into the solution, if this is my curve, this is my curve, and more likely the line is going to pass through the curve at different points, more likely at 2 points. More likely it will cut the curve at 2 separate points, which I can call P1 and point P2. In other words, we do the same thing. we know that at the point where the line and the curve are meeting, the line and the curve are equal. Meaning what we do here, we simply equate the two values of y, because at the points of intersection, the line and the curve are equal, meaning we simply equate the values of y. So you can come and say equating y values, because at the point of intersection, the curve and the line are equal. So if I say, if I equate the curve and the line, so I'm going to have a 2x squared plus 3x is equal to 5x plus 4. So we have such an arrangement, 2x squared plus 3x, when you equate the line to the curve. So when you look at such a phenomenon, that is a quadratic expression that needs just making it clear. So if I bring the 5 this side and the 4 this side, I have 2x squared, then 3x minus 5x, so minus 2x, then minus 4 is equal to 0. I can divide through everything by 2 here, by 2 here, by 2 here, by 2 here, so that I get x squared minus x minus 2 is equal to 0. So we can use the simplest approach, which can be factorization. So if I'm to factorize, I get the sum. We've looked at factorizing quadratic expressions, so I know you are good enough now. So the sum here is -1, and then the product is this times -2, which is -2. So I look for two numbers, which when I add, I get -1. When I multiply, I get I get a -2. So most likely it is 1 and 2 here, but then the sum should be negative. So this guy, the 2 is negative, it means it's -2 with 1. So what do I deal with these guys? I put them in the position of the sum, such that mathematically I've not changed anything. X squared minus 2x plus x minus 2 is equal to 0. I factorize x into x minus 2, plus there is nothing common here except a 1 into x minus 2 is equal to 0. This and this are common. I pull them out, I get x minus 2. If I pull this out, I remain with x plus 1 that is equal to 0, such that either I have x that is equal to 2, or x plus 1 is equal to 0, where I have my x is equal to -1. So for the value for x equal to 2, I come and I get the y value that corresponds to x is equal to 2. I know that 1y, if I use the line y is equal to 5x plus 4, to get the y value, y will equal to 5 into 2 plus 4, which is 14. Then for the other 4, then I have x is equal to -1. My y will equal to 5 into -1, 5 into -1 plus 4, whereby it is -5 plus 4, which is -1, such that the two coordinates of the point of intersection between the line and the curve are, I have there 2 with 14 and -1, -1, meaning my line is cutting the curve at 2, 4, and then -1, -1. Yeah, so